Nice to see a full room, ladies and gentlemen. So my intention is to educate you a bit about electrics. This is a bit of a first because there hasn't been an electrician speaking to the professionals that you are in CPD conferences for something like 20 years. This is what I'm going to cover, and this is a bit of a quick run through of all the stuff that you could talk about electrics, which is a vast subject like all of your subjects is. So wait a minute, we need to do this. So I've called these chapters, six chapters. These 5 here will all be in the notes that you have, but the introduction isn't. The introduction is what I'm doing now, just to sort of start the ball off. Who I am and where I'm from. My name is David Berg. I live south of Exeter, quite a long travel here, and I've been doing electrics for about 20 years. I've done a lot of different things in my life. I first learned I could become an electrician because I had a natural health centre clinic in London for 30 years, and one day environmental health came round. They said, "Has the fire department been here?" And I said no. They said, "We'd better send them round." Fireman came round, and he said, "Have you got anything that shows that the electric installation here is in good shape?" I said no. He said, "Well, you better get one, you've got a month." Right? I knew the state of the building. So without any very much experience, I was, every time the last patient went home at 9 o'clock at night, I was ripping up floorboards and digging holes in walls and running cables between 9 o'clock at night and 8 in the morning when the next patient would come round. It was exhausting, and it took me a month. And at the end of that time, a couple of electricians came and they spent all day checking my work, and the senior of them at the end said, "For an amateur, you did a pretty good job." That means I did it too well. Now, talking about what I'm here for, I regard this presentation as a bit of a practice, because what I'd really like to do is go into schools and talk to teenagers about becoming electricians, particularly girls. There are very few women in this trade. I once went to a training day for electricians, and I was gobsmacked. There were 100 delegates in the room, and I went to the front and I took a picture. There wasn't a single woman in the room. Now, half my clients, I work in domestic electrical field, half my clients are women. Given the choice, if they felt confident in the woman, they would go for a woman every time. So I've talked to a lot of young girls, daughters of a client I'm working for, about, why don't you think of training to be an electrician? Great trade. Now, I hope at the end of this presentation that you'll be able to be a little bit more professional and perhaps avoid getting sued, because sometimes the work that you're involved in, you will need to make an assessment, either yourself or an assessment of whether you need to get an electrician in to have a look, to give an expert assessment. So I hope you'll know a little bit more about the subject by the end of it. Now, one of the things I want to do, you'll be familiar with that sort of thing, one of the simplest electrical gadgets there is. I'm going to pass it around the room. What I'd like you to do is take the top off it, have a look inside, pass it on to the next person, and eventually it'll come back to me. So if you'd like to have a look at it, sir. There we are. Right. This is just to get you involved, you understand. You've all seen one of those before. Now, last weekend, my wife and I went to Cornwall, and we were near Polruan. There's a church there, I've forgotten the name of it now. And I saw this church, this is just last weekend, and I thought, I'm going to take this along to the conference. And here we've got a church tower, a very ordinary thing, and close up, we all know what this is, lightning conductor. And what I want you to notice about this is it's hardly visible. It's just a thin copper or aluminium strip running down the building to protect it against enormous voltages. So 2 things I want you to recall about this. One is certain metals are very good at conducting electricity, unlike brickwork. And the second thing is I want you to think electricity comes in different sizes. During this talk, I'm not going to talk to you in terms of volts, amps, power, or any other of those words because they're quite difficult to define and unnecessary in a way for you. But think, in this situation, it's protecting that lightning conductor, it's protecting this building against enormous electricity bumps. We're familiar in our lives with middle range, which comes through the sockets in the room, and tiny electricity, which happens in our mobile phones. Electricity, very important for our civilization. Take it away, your life would be completely different. Now, first of all, I'm talking about domestic installations. Much of what I have to say applies as well to commercial and industrial, but my experience is mostly domestic. Secondly, yeah, I've done that. Secondly, I want to tell you that electricity, you know this, is very dangerous. And this is an advert from a long time ago in America, I think. I put that in there because I wanted to have some visual bits. I thought electricity being invisible, a bit difficult to show people what it's like. Now, I've done that. Electrician's terminology can be quite difficult to understand. So in your notes, there's a page at the back about electrician's terminology. It's very brief, it's just one page, but it gives some of the common words that we use. And before we go any further, I want to remind you what a ring main is. And are these in order? What is a ring main? Here we go. This is a ring main. It's diagrammatic. I know not all of you will be comfortable with this, but a ring main means the cables, we've got cables running to every socket from the distribution board, which is this one at the bottom here, and it goes round to every socket, and then back to the board. So it's a ring with sockets on it. Now, can any of you see any of those circuits that aren't on the ring? In other words, they don't have a cable coming from the left and the right. One of those, yeah, that one?
And the other one.
And the other one, yeah. There are two spurs. Now, this spur is taken off a socket. This spur is taken off a junction box, which might be under the floor, and you'll never find it if you don't know it's there. The disadvantage with rings is that the fuse that we put there to protect the circuit, and fuses always protect cables, the fuse is designed for that ring to be unbroken. Now, that spur is okay, but people often add sockets in their homes, don't they? So one problem is people adding another spur to that. That piece of cable then could get overloaded, and the cable could get red hot and start a fire before the fuse there goes. I'm not going to talk very much about rings, but you may be interested to know England is virtually the only country in the world that has them. Other countries thought, not a good idea. Now, I'm going to move on to... well, wait a minute, before we do that, this is a very simple diagram of what you might find in a house. You can see at the top, fuse box, consumer unit, distribution board, DB. There's all words for the same thing. I'm either going to use fuse box or DB. DB is what us electricians do for short. Now, there's a ring. All other sockets serving sockets apart from rings are called radials, and this is a radial. I always think of it like a tree. It's upside down, in fact. Cooker on its own circuit takes a lot of juice, so we want to keep it separate. Lighting circuit, one thing of interest here, you've got a light with a switch, light with a switch, light with a switch, light with two switches. That might be on a staircase where you've got a light and you want to be able to switch it on or off from the top or bottom of the stairs. Two-way switching. Now, we've done... If you want to know more about ring mains, it's in your notes. Why do we have circuits? On this circuit, on this board here, we have one circuit for the ring, one for the radial, one for the cooker, one for the lighting. So we've got 4 circuits in this particular configuration. Why do we have circuits? Anybody have a guess at that? Okay, I'm going to answer the question as if I'd been asked. We have circuits. We could, theoretically, if everything was fine. You could just have one fuse there to protect everything, right? And that fuse there would be to actually protect the electricity supplier's cables in the streets. In case something went wrong in your house, we'd want to protect the cable under the ground because it's expensive to dig it up. We could have one fuse. The reason we divide an installation into a number of circuits is, one, for convenience, and two, nothing is perfect. Things go wrong. So if something goes wrong in a circuit, it at least has only gone wrong in that one circuit. Let's say your lights conk out, and you've got a trip switch, if you're lucky, got a modern board, trip switch switches out, you put it up and it goes down again. It's unhappy. It's tripping in order to stop cables overheating. At least only your lights have gone off, and you can say, well, we haven't got any lights until we get an electrician round, but let's use that standard lamp in the basement for lighting up the bathroom because there's no window in there. You know, that's convenient to be able to do that. Now,
you'd also need bigger cables if you were going to put them all on one cable. You need a much bigger cable if you put them all on one cable.
You would, that's true. Good point. Now, I'm going to move on. Have we got to this stage yet? Yes. Pitfalls following doing it yourself. Now, I'm not assuming, I'm not making the thought that any of you would work on your own electrics, although there's nothing wrong with it. Certainly if you're changing a light fitting for another light fitting, or changing like for like, as we say, no regulations apply to that. Anybody can do that. You can do any electrics you like. In fact, 2 people over the last 10 years, 2 men who were bringing up their house to a better standard, were rewiring the house. And each time, I've done a number of rewires, big job. Each time I negotiated with the man doing his rewire, and we did it together. Basically, he did nearly all the grunt work, and I was there to tell him what to do, and there at the end to check he'd done it to the standard that I would do it or better, and to sign it off, to make various tests and check it was all okay. And I remember the second man, I went in, because I went in for an hour every couple of days to see how he's getting on. And I went in there and I said, you'll have to take all those cables out again. You haven't done what I told you. Those cables are too near the edge of the joist. He listened very carefully from then on. So the thing is, he was doing that job under my very careful instruction. Most electricians wouldn't dream of doing something like this because it requires very good communication both ways. And many electricians, particularly electricians, it applies to some extent to other tradesmen as well, in this country, are not as good communicators as one would hope. How's that plug doing? Has it got round the room yet? Or, yeah, we'll come back to that. I don't know if everybody's seen it. If you haven't, I'll tell you what's inside it. Not being good communicators means that such tradesmen not only don't listen carefully to what the client wants, whether they're a big business or whether they're a householder with their own house, they're also not good at explaining. And I suspect a lot of tradesmen, and I'm most familiar with electricians and plumbers, are scared that if they tell you how to do something, that you'll go away, do a course over a weekend, and compete with them as an electrician next week. I think they're somewhat guarded about what they share. Whereas I love sharing about the stuff I know about electrics, hoping that people who are a little bit interested might learn a little bit. Thinking about pitfalls following do-it-yourself, things go wrong with nothing is perfect, as I said before. Things go wrong in the real world, and if something goes wrong with your electricity, usually this is one of these things. You can smell it, and probably most of you have smelled a rather disgusting smell when something electrical is overheating. To my nose, when I smell it, and it goes right back to when I was a child, I suspect, it's a scary smell. You hear it. You sometimes hear a socket sizzling. Not a good sign. There's sparking going on inside. You see it. You can actually see flames coming out of something. Or you feel it through touch. If you touch something that's live, it makes you jump, and you think, better do something about this. So your senses are very important. You can even taste electricity. I did this when I was young. I would test a battery by putting the thing on my tongue, made a little tingle. I didn't realise that there's a big difference between AC and DC. My electric train set was 12 12 amps AC. And I put it on my tongue. I've never done it again. It was horrible. It was really horrible. Now, if you find something wrong with your electrics and you can't work out what to do about it, you need to call an electrician. How do you tell who's a good electrician? Well, the same probably as in your trade. Personal recommendation is best. Otherwise, electricians who are qualified work usually under one of the self-certification schemes, as they're known. NIC, EIC is the best known, going downhill fast. NAPIT, which I belong to, is another one, and there's Stroma, and I think there's another one I don't remember the name of. And these schemes allow an electrician like me to do the paperwork in order to comply with Part P and to inform local building control that such a job has been done. And basically it hardly mentions the householder's name, but it will mention the job done, like change a consumer unit, who did it, the date, and so on. So if somebody dies 10 years from now and some investigation proves faulty electrics, they can pin down the electrician responsible. I realise I've been speaking without a break. Any questions so far? No? Let's talk about this plug then. Now, this plug is something I found within the last month in a property. I took the plug off the end of a cord, opened it up, and was very surprised at what I found. Can anybody tell me what's wrong with what's inside this plug?
Two things. Tinfoil.
Tinfoil, yeah?
What I was going to say is it shows that the person thinks that tinfoil conducts electricity.
Tinfoil does conduct electricity, perhaps not as well as a piece of wire, but it does. What's wrong with this is they bypassed the fuse because they didn't have a spare one. Not an uncommon thing. The problem with that is this fuse is there to protect the cable, and if something went wrong, the cable coming out of this plug going into a toaster or something like that, if something went wrong with the toaster, this fuse is meant to blow before the cable gets hot. That wouldn't happen if you'd done this. So this is a bit stupid. That's all. Another one that's very common, this comes from statistics of London Fire Brigade of I don't know how many years ago. 9 out of 10 fires in London where there is a smoke detector that's a battery one, not a mains wired one, 9 out of 10 times the battery is missing. Now that tells me that we, because I include myself in this, we are pretty stupid because the thing goes off at 3 o'clock in the morning, of course. It's warning you the battery needs replacing. You take the battery out because you need to sleep. And you say to yourself, I'll get another battery tomorrow. Never happens. So that's why the electricity, the organisation, pushed forward having smoke detectors hardwired with wires so you can't forget to replace something. Now, as you don't have any questions, let's move on to what we've got here next. Have you ever been in that situation where you're going to hang a picture on the wall and you just wonder before you drill into the wall whether there's any cables in the wall? Well, prior to, I actually looked up the date, prior to 1981, there has been a regulation about where you can put the cables, because remember, most of the cables, most of an electrician's work is invisible. It's cables under the floor, in the walls, up in the ceilings. Now, most of the cables are invisible, so you don't know where the cable is. So the regulation says if there's a socket, say here, then the regulation says you must regard these up and down and left and right. You must regard those as what it says in this regulation, prescribed zones. In other words, don't drill there because there may be a cable there. Remember, nothing's perfect, so the cable may not go like that. It may go, the electrician was a bit, it sort of goes like that. However, the general principle is steer clear of above and below and to the sides. And also, there are two other zones in the corner, whether internal or external, 150 mil. You can put a cable that way or this way. Now, interesting fact, about 6 weeks ago, one of my subcontractors who works for another electrician told me that that's an okay place to run a cable. I said, it's not. He said, it is. And I showed him the picture in the book. And he went back to his boss, who'd been teaching him as a qualified electrician for years, and he had to tell his boss he'd got it wrong. none of us is perfect. Another one I can show you. This is a regulation that is more to do. It's in our regulations, but it's more to do with the structure of a building than to do with electrical safety. If you're running cables under a floor, it's easy when you run the cable between joists. That's nice. But if you have to go across joists, there's usually not a gap to push a cable through. So you're either going to drill a hole like that in a joist and run your cable across the room that way, or you make a notch in the top of the joist there, and that looks like a pipe to me, but this is a cable. You run a cable close to the surface. Now, given the choice, I prefer always to do that myself. However, if you do it at the top, there is a risk if you're nailing or screwing your floorboards down that you will go into that cable. So it should be that you put, I keep pointing, I'm not used to a pointer, these metal plates to protect the cable over the joist. And in fact, I think this isn't a very good diagram, because what I do, that cable, I bring it, once it's come through that slot, I bring it down like that. So that there's minimum chance, because at the moment you could screw a screw into there, even though there's nothing underneath that cable, it could damage it. So that's something that people aren't aware of very much when they do their own electrics. Now, connecting the earth wire, does anybody know why we have an earth wire? Because if you travel to other countries, you often don't have an earth wire. They have live and a neutral, no earth wire. What's the earth wire do?
Isn't it supposed to conduct away some of the voltage to the earth? So instead of getting a full electric shock, most of it is carried away.
That's a very good answer. Yes, thank you for that. I'm going to move on to the next slide. Metal conducts electricity. I said that right at the beginning. Some metal objects you're familiar with that have electricity inside them are a cooker, a washing machine, a metal box, basically. Now, this is a diagrammatic, we love diagrams in our trade. This is a diagrammatic picture of a cooker, and as you can see, thick cable running into the cooker with a live, neutral and earth inside. Now, should something happen, remember I said nothing is perfect in this world, should that live wire come undone and touch that metal case, that metal case will be at 240 volts. And this man might be lying on the floor unconscious or even dead. Sorry he's a man, but nearly all the pictures have men in them. The idea of earthing, as the gentleman over there said, is if you earth the case, which we do, then if that live wire touches the case, the electricity will come in along live, and instead of going back along neutral, it'll go to the case and go back along earth, back to the distribution board, and the fuse will go bang very quickly. So it will cut out in a fraction of a second to stop that going live. Now, in fact, if that happened inside there, if the live and earth were touching, you would not be able, if it was a trip switch, you wouldn't be able to push it up. You push it up and it come down again. It won't stay. If it's an old fuse, like in this plug here, if it was a fuse, it would blow and it would break the circuit so it wouldn't go anymore. So that's one reason we put an earth in. I'm going to have a sip of water. Get a dry mouth talking non-stop. It's why you should ask more questions. It's to give my throat a rest.
Okay, can I ask a question?
Please do.
Why is it in Europe that they don't have an earth wire?
They do in some places, they don't in others. And I don't know if I can answer that question. I think England is one of the safest countries in the world for electrics. That may be the reason. It's cheaper to produce a cable that doesn't have that third wire in. Also, if your population is used to it, then why bother? If the number of deaths or injuries due to electrical problems are greater in France than here, would we know? Does anybody talk about that? So I don't know if I know the answer to that question. I've been on holiday in Egypt, where in the streets, and they're very untidy with everything, you've got drooping cables and somebody needs a wire, some power for their television, and they come into the lighting circuit and they just twist it on like this, probably using rubber gloves, and you see the cable into their house. We would not consider that safe in this country. But in Egypt, it's not an uncommon sight in villages.
The other one's America. America has just 2 lines as well.
Some of them, but they've only got 110 volts, which doesn't kill you as easily. So yes.
Sorry, can I just ask you, on the previous slide you said that a cable wouldn't be okay running, I think you said along the bottom, sorry, on the previous one where it was zoned.
Zones, yeah.
Yeah, but why is that?
Let's suppose you put a socket here, and you need to get a cable. The cable's coming under the floor, and you've done it diagonally across there. You would think that this might be an okay place to drill into the wall because you want to put a low-down shelf.
Oh, okay, so you weren't talking about horizontally across the floor?
Yes, horizontally, yes. It's the cables from a socket or light switch or anything electrical. If you've got, here we've got an example here. The cable, whoops. Does anybody know how to sort this one out?
Yes, calling the electrician.
I shall continue. There we go. This is an example of an electrical accessory, and the cable to there should either run vertically down from the ceiling or up from the floor. Thank you, sir. Brilliant. Lovely when people know what they're doing. Or the cable could run sideways. What shouldn't happen, and we rarely find, but it does, is a cable running diagonally or doing this, because there's nothing to say that there's a cable running up and down there. So that's the regulation. The reality is that we go into houses, and particularly if they're 60, 70 years old wiring, we find all sorts of things. But this is what you should find. It's designed to keep us all safer. Another reason for an earth wire, imagine you've moved into a new house, or it's an old house but it's new to you, and you don't like the white plastic switches, so you get some nice Georgian ones that match the other things in the house, and you change all the switches all over the house for these Georgian plates. And they're of course made out of metal. And imagine, similar to this, inside your light switch, if the live wire touches the metal of the switch, then that switch will be at 240 volts. If, however, the switch plate is earthed, as it should be, then it will cause a fuse to trip, and it will save your life. You imagine you're switching a switch on, bang.
Don't touch that.
Sorry?
Don't touch this.
Don't, thank you. I always listen to good advice. Thank you very much. Now, a couple more things about jobs people do for themselves. Changing a shower. Now, the one thing about an electric shower, changing a shower, you might say, well, I've got the same model, it's going to fit all right, the pipework will fit, I can wire up the electrics, that's all right. What you didn't think of was that your old shower was a 7.5 kilowatt, protected by a 6 mil cable, protected and at the fuse box by a, let's say, 32 amp fuse. And you've gone and bought a 10.5 kilowatt shower because it said on the box, gets nice and hot. Well, it said it another way, but that's what you wanted. You want a good hot shower. What you don't realise is that you're running that shower for 10 minutes and the cable is getting hot. Now, that's all right because the 32 amp fuse should protect that cable. But remember, we never rely on things because nothing's perfect. If that 32 amp fuse chose to be 1 in 1,000 that didn't work, that cable's getting red hot and starting a fire. And that was the cause of that was you, I'm sorry to say you, all right, the person, changing their shower for a higher power one without thinking about what they were doing and perhaps getting advice. Another thing we were talking about, we'll go back a few slides, we were talking about, doesn't work anymore. Don't understand why not. We were talking about running cables under the floor. You imagine you've got this hefty cable for a shower run under the floor, it's notched through joists, and one of the joists where it's notched is under a floorboard, and you walk on it going up the stairs, and over years you keep squashing that cable. And that then becomes a weak point in that cable. So if anywhere along that cable is going to go, it's that place that got damaged because you allowed a cable to go through a place where it gets squashed over and over again, eventually damaged. Okay, so let's go back to there. We'll jump now to one that happened about, this is something that happened about 2 months ago. I was in this woman's house in Totnes, and she had a problem with a particular circuit causing her RCD to trip, and I had to find out what was causing that, and there were about 6 sockets on that circuit, and she said, I think it's that one. I always take notice when people have a thought like that. So I opened up this socket, and I said to her as I took it off the wall, there's some odd stuff on here, look at this. And it was like there was a sort of deposit on top of the metal inside, the metal contacts where you put the wires in. And I pulled it out further. Oh, there's a slug in here. And oh, the slug's still alive. Now, what had happened is somebody had drilled a hole from this socket outside. And when we go through a wall in a building, we always go down from in to out to make sure water is less likely to come in. So they've run a cable out from that socket to have a spur on the outside for an outside socket. All very good. They didn't seal the hole. And a slug came along one day and said, this looks like a nice place to live, and went in there. And I don't know why, but the slug could walk safely, or slime, on top of the neutral and earth. Connecting neutral and earth together actually causes an RCD to trip. Didn't harm the slug, so it's still alive. But that slime, a little bit of slime inside, had caused that problem. Now, it could have taken all day, several £100 for me to find that problem. It actually only took about an hour. So I took the socket off, put a new one in there, and carefully took the slug into the front garden. Now, we're going to next, let's see if we've got next, certificates and reports. Now, certificates and reports is possibly one of the things that you as professionals may come across more than these other things I've been talking about. Remember, I'm trying to talk about a vast subject and try and find bits and pieces that might be relevant to you. Now, there's one report that you might see and several certificates. The report is we call it an EICR, Electrical Installation Condition Report. And, I want to say I'm going to spend 5 minutes on paperwork. If you want to go to sleep now, get the person next to you to nudge you when I'm finished, because it's a boring subject, paperwork, for all of us. There are 3 sorts of certificate I do, 2 sorts of certificate and 1 report. One of the certificates is a minor works. That might be adding 4 sockets in your garage, running off a fuse spur into your garage, and you want 4 sockets in there, didn't have them before. That's a minor works. An electrical installation certificate is needed to be given for any other work, like changing a distribution board, adding a new circuit. You might say, we haven't got an electric shower, we want an electric shower. There is a space in our board for another trip switch. Let's wire in an electric shower. That's adding a circuit that is both notifiable to the local council and through building regulations, and also it needs a certificate, and a copy of the certificate is kept and hopefully retained by the client, and I keep a copy for 10 years as well. Now, what I want to say, mostly the ones that are useful to you are going to be the EICR, the Electrical Installation Condition Report. Now, nowadays, estate agents particularly are encouraging more and more people when they buy or sell houses to get one of these reports done. Previous to about 10 years ago, people didn't bother that much. I mean, you moved into a new house and you discovered how good the electrics were as time went by. Now it's a factor because we need to know more. Buying a house, what are the status of the electrics? And the only way you're going to know is getting a report from an electrician. And that report will cost, well, my minimum charge is £130. It depends how complex the installation is. And the report, just some pieces of paper, is a very valuable document if you're selling that house. If it says at the end satisfactory, because from your point of view, if you get to see one of, has anybody had the opportunity or the challenge of seeing an electrical report like this? Oh, great. So some of you have some familiarity. There's a lot of information in it. Most of it is only interesting and useful to other electricians. However, the most useful things from your point of view are the address, is it the right address, the purpose that the report has been commissioned, whether it was satisfactory or unsatisfactory. We don't have pass and fail, we have satisfactory and unsatisfactory. And there are fairly minor things that might allow a report to be regarded as satisfactory, even though they aren't perfect. But if there's any code 2s or code 1s, a code 1 means you put your hand on it, you electrocute yourself. that needs to be remedied straight away. And there's another category we have called FI, further investigation. In other words, until we've spent more time examining this, we can't tell whether it's safe or not. Now, the most significant, most useful part from your point of view will be the summary. And if you've got an electrician who's good at communicating, the summary will be useful to you. However, a lot of electricians may have done a good job in their investigation, and they've written a summary that is pretty hopeless from your point of view. And I'm going to read you, I'm going to read you 3 summaries extracted from different reports that I've done. So they're fairly brief, that's why I hope you'll indulge me in reading them out. So one of these reports says, of immediate concern are 1, the failed 2-pole RCD in the shop distribution board, and 2, the emergency nights needing attention. And 3, more investigation needed. See letter sent with this report. Now that is pretty clear, I think. I try and communicate clearly. Another summary from a different property. Nothing untoward seen. The heads of the 3 fixing screws holding the cover on the electric shower are very worn and should be replaced. Otherwise, when the shower needs to be opened, it may not be possible to get the cover off without breaking it. Now that is not an electrical problem. But it will be a problem if the person, anybody in the future, takes the front cover off and can't get it back on again, because suddenly you've got an electrical problem. You've got a live thing on the wall because the cover is off. So it didn't cause an unsatisfactory, but it did bring it to somebody's attention. And the last one, it's a tiny bit longer. The installation cannot be considered safe without a large number of issues in the house and the 2 sheds being addressed. Also, a more extensive survey is needed than is noted in this report, and it is suggested that the most economical and efficient way to do this is to replace boards DB1 and DB2 with a new board so that testing can be carried out fully without the risk of not being able to reassemble the connections when they're taken apart for testing. Again, I think that's a pretty clear summary. We're going to move on. Any questions, please?
Yeah, the 3 examples you've just given, is that just from the standard EICR?
Those examples are all from EICRs. Yes, I don't know what a standard EICR
Well,
is.
yeah,
They are. And there are more. If you're interested, there's more detail in the notes about this. It's a bit paperworky. It's a bit full of detail.
Can I ask? I asked some. So I had some minor works done. Which
Why has
I had some minor works done at my property, and the electrician was so reluctant to provide kind of any documentation or certification. I did get it, but why?
Okay, my opinion, because I don't know him, my opinion of another human being who's an electrician is a lot of people are drawn to become electricians because they like fiddling. They're good at sorting out problems, all right? They may not, and some of them are not so good at reading and writing, and certainly quite a lot of electricians, including some guys I know, are very reluctant to do the paperwork, even an invoice and a receipt, and they'll take 3 weeks to do a quote for somebody, which I think is stupid. You lose the job. So I don't know why, but I think one of the things, if you're employing an electrician, you can ask him up front, are you prompt with the paperwork that you need to deliver to me at the end of the job? That's quite a nice question. 3/4 of the electricians will say, oh, I'm sorry, I'm too busy to do your job, I'll go somewhere else, because they're not very happy doing the paperwork. It also, to my mind, leads to the possibility, how many of these people produce what I would call crap paperwork? Because through my assessor, every year I get assessed about whether I'm competent to keep doing the work that I'm doing. Through my assessors, I've come to understand how other electricians are, and there are even experienced electricians out there who are doing things very badly. Paperwork is one of those issues. And the industry, if I look over the last 20 years I've been involved, is getting better and better year by year, stricter and stricter, more and more expensive from the client's point of view, but safer and safer. So the quality is going up. The training that young electricians nowadays have to go through is absolutely immense. I don't know if I could do it, but I hope that answered your question anyway. Yeah. So,
So you mentioned it's roughly £130 for the ICR.
I said that's the lowest. That's a very simple board. Now that's me.
Yeah, I know they can go up to 300. Can you give prices for a rough price for rewiring the house?
Yeah. I'm going to answer that question in a very general way. I've put at the end of my notes my contact details. Now, I live in a different part of the country probably than most of you because I don't recognise any of you from Teignmouth. But should you need electrical advice, I'm very happy to talk to somebody for 5 minutes on the phone. Right? If it's going to be a quarter of an hour, I'm going to start charging you, and that's fine. I'm quite reasonable. I'm very happy to support people in either doing it themselves, how to do it before you start, ideally, not when you've caused the problem, or helping you plan, or to answer general questions. So I can help show what I would do. And for instance, unusually amongst electricians, I don't quote for doing a rewire. Well, sorry. For a rewire, I need to look at the property, or at least to know how many rooms there are, how many sockets in each room, how many lights and so on, and I can do a calculation and work out what I would quote. So yes, and that would give you a ballpark figure. However, I will say, and this applies to any business really, if you go for the cheapest, amongst electricians, what are you actually getting? You're getting electricians who cut corners, who don't know the regulations, maybe they're not even qualified. And they may charge half of what I do, and the problems that they may create may not appear for 10 years. So you won't know. And I have to say my opinion of an awful lot of new build in this country is the electricians employed are told, hurry up, do it quick, and also we don't pay you much, so you're working for us because you can't get a job anywhere else. The electrics are awful. I've been into quite a number of houses that are 2 or 3 years old, and I've said, who did this? You know. Anyway, I'm sure many of you are familiar with that sort of scenario. Let me think where we've got up to. Oh, how interesting. We've got on to older properties. This is really quite a general thing, but one of the things you should be aware of is bathrooms are special places from an electrician's point of view. Bathrooms from an electrician's point of view are special places, as are swimming pools and so on, because electricity and water together. Now, water doesn't conduct electricity very well, but it conducts electricity much better than a human body. Basically, it conducts electricity. So if you have water and electricity and you've got bare feet or you've got nothing on at all, it can be dangerous. So there are zones in bathrooms, and in fact, if you go to buy a light fitting for a bathroom, you may even see on the box, if it's suitable for a bathroom, it'll have zone 2 fitting. There used to be a zone 3, there isn't now. So zone 1, which is, if you like, above a bath, below a shower, up to a height of 2.25 metres, which I know is exactly that height, so I never need a tape measure. That's zone 1. Zone 2, up to 60 centimetres from the edge of the bath or shower, that you can put a very limited amount of electrical fixings in there, but you don't have an electrical switch, not a rocker switch on the wall in bathrooms at all. You always use a pull switch because the electrics are all tucked away in the ceiling. You may not, I got this from the internet and they've missed the yellow bit there. They've shaded it in, so it's around the wash basin there. It should be yellow as zone 2. It says zone 2. So this was about older properties, yes. And this is a new regulation. When did this come in, this regulation? Came in the last, I can't see here. This regulation came in the last 15 years, I think, and it's about our increasing awareness of disabled people. Please.
On the previous slide,
Yeah.
When you've got a wet room rather than a bathroom or a shower room, so there's no shower cubicle,
Yeah.
how do you go about measuring the zones for a wet room?
I believe, I'd have to look it up, right, but I believe the whole of a wet room would be zone 2, if not zone 1. I'd have to look it up. And in fact, this is the book, it's referred to in the notes, this is the book that we use, us electricians, Requirements for Electrical Installations, or BS 7671 for short. You might like to take a minute or two to come up here afterwards and have a look at it. It's the least readable book I have ever come across. I never bother to look anything up in here. I belong to NAPIT, and I ring up the engineer at the end, and he knows the book inside out, and I'll ask him anything. I would ask him that question about the wet room, and he'd tell me it's all zone 1, and then I'd know. I said, good, I guessed that. Now, we were going on to, oh, that's right, disabled. So, because of our increasing awareness, only recently really, about disabled people struggling with all sorts of things, minimum height above the floor for sockets is 450 mil, and the maximum height of light switches, we're used to light switches, this tells me the age that this was done. That's the height of light switches in the old ways, there or about, somewhere. We bring it down to about here, 1200 from the finished floor level for switches. And basically you can put switches and sockets, anything between those two heights. Not only disabled people, I've got some very elderly clients who say, oh, I really like that new socket. I can reach it. Because when you get very old, you know, getting down to the skirting board to plug something in is very hard. So it's an obvious thing. So these are the new heights, and we're talking in this chapter, as I call it, about older properties, yes. So older properties won't have the new heights necessarily. Let's see what else we've got here. This is an example. All cables have to be covered with 2 layers of insulation. You may notice here, this is a pendant. Don't have any in this room because it's all modern lights, but you know a pendant's got a rose on the ceiling, a cord, a lamp holder, and a lampshade maybe. And I still go to houses that are looking like this. And here is an example. This cable, the flex, has a green in it, a yellow and green in it as well, but it's got a brown and a blue in it for live and neutral. And that is insulated. That's each of those copper conductors is insulated, and that's outer insulation. So there's 2 layers of insulation. There should always be 2 layers of insulation between the live parts and you. And this is an example that on an EICR, it wouldn't fail it wouldn't be unsatisfactory, but it would be a code 3, could be improved. It looks unsightly as well. It's actually quite a simple job to unscrew that, to pull that cable up a bit into the ceiling so you don't see those. But it's an example of something that is not well done. So I would think whoever did this either didn't know, didn't care, or was in a rush and they didn't do it properly. Older properties, and most properties in this country are old ones. Now, going back to talking about plugs, that is a well-wired plug. And you can see the insulation, the primary insulation, goes right up to the terminal in each case. Can't see any copper there. The next slide, what is the next slide? Oh! Can anybody see why this is not wired so well? Something there, yes. Piece of wire wrapped around the terminals, possibly, yes. Anything else?
No earth.
No fuse.
No earth, no fuse. Some of that secondary insulation is showing there. The cord grip there isn't gripped on that bit, it's gripped on there's a lot of things wrong with it. I thought I'd show you that. I just came across it on the internet. This is something you may have seen before, which is a plug that is obviously unhappy. Now, it's unhappy, and it's also left a mark, because that mark has been caused by that, because it was plugged in there. So I can only guess, because I just got this from the internet, but that burning mark is probably due to the fact that years ago, somebody who put this plug on didn't do one of the terminals up tight enough. And in fact, that terminal is the neutral. No, it's the live terminal. Because they didn't do the screw up tight enough, because it needs a screwdriver and a bit of action with your wrist, then the flex inside the thin copper fibres that were inside that connection weren't properly making contact with the copper or brass terminal block. So there was a gap, and that means sparking. So that was probably fizzing for years. And sparking makes heat and light and eventually is going to burn something out. It's not what you want, but probably due to carelessness. It could be due, let's say 1 in 100,000 times, to a badly manufactured plug. And the quality of all electrical goods has dropped in the last 20 years just because everybody in the world says make it cheap. Back to a distribution board. I want to tell you something about the distribution board so you have more familiarity with it. I have had this several times where I'm rung up by an old lady and she's got a distribution board. Well, she may not even know about this, but she says her sockets have stopped working. And I said, have you been to the distribution board and seen with one of your trip switches has gone? And she says, she's an old lady, she says, my husband used to do all that. Now that is sad because, you know, it's why girls should learn just as much as boys about doing stuff. But one of those tripping might happen if there was a problem with the circuit, and it's there to protect you. It's to stop the cables getting hot. Now, in fact, the old lady or whoever it is simply goes up and they get hold of the switch and push it back up again, and that may be it. It may have been we don't know the reason, something happened, caused a trip, problem's gone away now, forget it, right? But the point is, this box is safe. This happens to be a metal box, could be plastic. It is designed there to protect the cables, and it's there to be useful. So I'm going to introduce you to the elements of this. Main switch stands out in red, marked main switch. And then you've got the trip switches here, which are the equivalent of fuses. They have an advantage compared with a fuse. A fuse blows, and you can't even see it's blown very often, but you could take it out and put one that was good in there, and it goes again, you know it had blown. But it's not very easy. You have to undo something and go and get another fuse. So fuse, also, there's a danger with fuses of people putting the wrong size fuse in. That applies to 3-pin plugs, which you've got 13, 5 or 3 amp fuses in, and 10 if you're very unusual. Trip switches are easier because if something goes wrong, instead of a fuse blowing, that trips down and up is on with fuse board. Don't ask me why, it's the opposite of light switches conventionally, but that's how it is. I think it's because we copied Europe many, many years ago. But anyway, a trip switch will trip if there's an overload. So if you try and take 10 amps from a 6 amp circuit, eventually, and it doesn't happen instantly, let's say in 5 minutes, the trip switch will go, and that's to stop that cable getting red hot. And you can just switch it back on again. And if there isn't a fault any longer, or if it's an intermittent fault, sorry, you're yawning, sir, not too long to go, really. So those are trip switches, the most common sort of protection. Now these things are called RCDs. Very, very few people in this country who aren't electricians know what it means. It stands for residual current device. Well, what's that set of words mean? The important thing is this is a new invention 30 years ago, 40 years ago maybe, used all over the world. Very clever device. What it does, it only works if you've got an earth. And what it does is it checks that the electricity going from your distribution board to your toaster or your washing machine goes out along the live wire, goes through the motor of the washing machine and comes back along neutral, back to the board. That's how, if everything's working well, that's what happens. Now, if something's gone wrong and some of that power is going out on live and coming back through earth instead of the neutral, even if it's a small bit, that will trip. In fact, that will trip, it's got it written on it, 30 MA, 30 milliamps, 30 thousandths of an amp. It will trip if that much electricity is coming back through the earth rather than through the neutral. Why do we have these? Well, it takes 50 milliamps to kill a human being. So the theory is that if something went wrong, and we call it an earth fault, if something went wrong in one of your circuits, and this RCD looks after those 3 circuits. So if something went wrong with one of those circuits, and there was more than 30 milliamps going to earth from live, this would trip. And if I tried to switch it back on again, it would trip off. And they've probably saved millions of lives, these RCDs. Whether they have or not, I don't know. I've tried to look up statistics. I've never been able to find any statistics that say RCDs work.
Why is it 2?
Why the 2? This is called a dual RCD board. Main switch, 2 RCDs. And the MCBs, miniature circuit breakers, are divided into 2 groups, the left and the right. And it's because if this RCD trips, let's say this circuit has got a problem on it, this trips and can't be reset, at least you've only lost those. You've still got these. So that's why you've got 2 RCDs. However, I don't fit these boards when I'm asked to fit a board, I only quote for a board. Have I got a picture of one here? I probably have. I only fit a board that has, can you see each of these has got a push button? I'm going to go back for a second. There's, on this RCD, each of them has a press button as well as a trip button. The test button is there because once every 3 months or once every 6 months, you should go and test this by pressing that, and this should click down. Now, they call it a test. It's not really a test. What it's really is that if that sat there for 5 years, never tripping, and then there was an earth fault and it needed to trip, you know how mechanical things are. They seize up a bit. It might not trip. And I've actually come across this personally. In a new build place, there were 2 of these boards, each with 2 RCDs in. And when I first tested them, none of the RCDs were okay. They failed the test. And when I'd done this once, they worked. So what had happened is they'd sat in the same position for so long, maybe there's a deposit on the metal or something, they didn't trip. So it's very important to do this test, this keeping things moving once every 3 months or 6 months. There should be a label on there saying it. There we are, important. That's what that label says. And all over the country, perhaps probably all over the world, people don't do this. 1, because they don't know, 2, because they don't remember, and 3, because they don't care. I really don't know. However, the thing will not work if it doesn't happen to have tripped. For a long time, it will stay on, conducting electricity when it should trip out to save you. We were going forward a bit. This was an example of, these are fuses inside these. And you can see one of them's missing. You can also see there, you can see I'm in the middle of doing something. This is a ring main, obviously. There's 2 brown wires there and 2 blue wires there. So I'm testing that particular circuit, and I'm halfway through, and I thought I'd take a picture. So here we've got an on switch. You've got, these are fuses in fuse carriers. And the thing I want to point out to you, this is something you normally wouldn't see because you don't take the cover off the front of a board. But as an electrician, when I look at that, I think that's a mess. That's hard to work on. It's difficult. I might have to straighten things out. Testing is laborious. There's also not much room in this board because it's an old board. They didn't give enough room. Contrast that with a modern board. This is one that I probably did. Now, that's not only neat. It also, if I see that, I'm given confidence in whoever it was did that work and any other electrical work. So, and it certainly is far easier to work on. And here we've got a new device. So you've got your main switch. I won't count that at the moment. These are all combination miniature circuit breakers and RCDs. They're called RCBOs if you want the proper word, but each of those is an RCD on its own. So completely separate. There's something special on this board, that thing. Now this has only been fitted in domestic properties as a matter of course in the last 2 years. It's actually a surge protector. You've come across these if you've got an expensive hi-fi or television or computer, and you plug something in, and you plug this surge protector in, and you plug your plug into that, and it protects your equipment in case there's a surge or a lightning strike. Now, the government, for some... Go on.
So what's the difference between a residual current device, an RCCB, and that last thing you mentioned?
Okay. RCCB and RCBO are virtually the same thing. An RCD is a separate, usually an RCD is a 2-pole separate device. Both the other 2, the 4-letter ones, are a combined RCD and circuit breaker. You may find those definitions on my page of electrician's terminology. Any other questions?
Yeah, I've just got one question. It might go a bit beyond the scope, but I always was wondering if you have an RCD protected consumer unit and you take out the RCD and you change all the circuit breakers to RCBOs, what do you do with the wires that were connected to the RCD?
Is it a board with one RCD in?
It could be one or 2.
It's either an RCD used as a main switch, so it's a combination main switch and RCD which protects all the circuits in one go, in which case you just put in a switch that isn't an RCD. You put in a main switch that's just an ordinary up and down switch, 2-pole. Or you've got the dual RCD board, and if you're replacing the circuits in there with RCBOs, you'd get rid of the 2 RCDs, and you'd sell them on the internet because you can get money for them because they're expensive.
Yeah, but what I mean is, but behind the 2 RCDs, there's additional cables. How would those be connected into the?
I see what you mean. It does go into more than we have time for here, but if you want to ring me up or talk to me in one of the gaps, I'll talk it through with you, because it's a good question, and it's fairly simple, but I don't want to take up time of everybody. Is that fair enough?
Yeah, it's a bit beyond the scope of.
Yeah.
David, you could just leave that RCD in place, couldn't you? You don't have to take it away.
If it's a dual RCD board, no, because the board is divided into 2 parts, and you'll find there are different neutral bars for each side of the board. So it needs thinking through, basically, before just removing something. But we need to be quite specific and say this is what we're facing, and now what we do about it. Yes, sir.
Yeah. A lot of the consumer units that we see are plastic.
Yeah.
And there's been a move more recently to metal boxes.
Yeah.
Why the change?
Oh, okay, good question. Now we have to fit metal. There was a year, about 2 years ago, we had the choice between metal and plastic. The theory is that if there was a fault inside the distribution board, inside here, that caused a fire, by having a metal box, you are slowing or reducing the risk of that problem of fire. I mean, there's not much to burn in there, but supposing there are holes in the top where cables come in, supposing somebody didn't fill them, sawdust got in there, little insects got in there, and there's a lot of stuff that can catch fire. So a lot of assumptions. Having a metal box would contain that heat and slow down or reduce the risk of it catching other things in the house.
We'd be recommending replacing it with a metal box.
That's an interesting question, because some electricians would say yes, should be replaced. In fact, the regulations say it only needs to be replaced if it's under a wooden staircase that is also an exit in the case of a fire. Now that's a very obvious place. Some old consumer units are under the stairs. We think nowadays stupid, but if it's plastic, regulation says it should be replaced by metal. Otherwise, if I was doing a report on it, I would say it's unsatisfactory because of the risk. And another place is if the distribution board or fuse box is in a place that is a fire exit, like it could be in a hall by the front door, and that's the one place that people would escape. And so it should be metal to help protect things. How much of being a metal is to protect the inside from fire if the fire is on the outside? Because of course, if a fire burnt through a plastic box, in your books, but not on in your booklets, there's a picture of my sister's house that caught fire. I might show you a slide of that. And her plastic box is all horribly melted and blackened inside. Not caused by a fault in the board, but you've got a fire. If this is a plastic box and a fire heats everything up here, you've got problems with wires touching each other, like live and earth and live and neutral touching it, and possibly causing sparking in another fire, and horrendous problems. We don't need it. So metal box is a good idea. Why they didn't come in years ago, I don't know, because there are some fuse boxes from 30 or 40 years ago that are metal. I know why we produce them in plastic. It's cheaper. Any other questions? Yes, sir.
Just a quick one. If you've got your consumer unit underneath the stairs, which is the means of escape, should you have a smoke detector in there under the stairs as well?
It would certainly be something you could argue, but under stairs or a means of escape. Choosing where you put a smoke detector is quite a good thing. You have to think in terms of, one, where air flows, and two, what areas you need to detect. So, and an attic space is another one similar to that. If you never use the attic, is there any point in putting a smoke detector there? You use it occasionally for storing stuff, well, maybe it should have a smoke detector. Depends on whoever's making that decision, I think.
See, I normally tell clients this should be a non-combustible box.
Yeah.
And I tell them it shouldn't be, is it over 450 millimetres high?
This same regulation as the switch should apply, however, not all electricians would agree. So I don't know.
And they shouldn't be in a bathroom as well? Downstairs WC?
Unless it's in a cupboard, I think it shouldn't be in a bathroom. I think in a WC, it may be okay. I would actually get advice if somebody was asking me about this.
So how would I know when to advise them if they need a rewire or not?
Look, it's a difficult decision for an electrician. How am I going to give you the advice? That's a tricky one. Rewire is very expensive. It fills your house with dust if you have to chase through solid walls. You've got to redecorate afterwards, and it's noisy. I mean, we do a rewire as a last resort, to be honest. And if you have a specific, and you've got 5 minutes, give me a call, and if I can take 5 minutes off, I'll tell you what questions I would ask to check that out. And then you'll become an expert. You've done that 2 or 3 times, you're an expert as much as me on how to assess when a rewire is necessary. Okay? Yes, sir?
As a surveyor, my view would be I don't necessarily need to recommend a rewire. If I have any doubts, I need to recommend an EICR.
Or, yes, I agree.
And an EICR would confirm whether it needs a rewire or not, is that right?
It should, an EICR, it shouldn't recommend anything. It should just report on what's there. But in the summary, it may say, may mention rewire, yes. We have to be very careful because the EICR, like an MOT, should just report on what's there and not what you should do about it.
Alright.
Yeah, so, but I have to say most EICRs I read are written by people who could have done it better, and so it might well say needs a rewire.
So if you've got an electrical installation certificate done, say, within the last 5 years, do you still need an EICR?
If you've got an EICR.
If you haven't got one and you've got an electrical installation certificate.
Again, I think a number of electricians would get this wrong. If you've got an installation certificate, for instance, somebody built a garage and they ran a new circuit for that, produced an installation certificate, that installation certificate, if you read it carefully, will mention that it didn't check the rest of the electrics. It only checked the garage, the bit that they did. So yes, you might need an EICR. Even if because the thing is, when you do an electrical installation, thinking about one of these boards, if we just put a new circuit in here for the garage, we're obliged, because we've touched this board, to check each of these circuits. But the check is very cursory. Basically, we go to the end of the circuit, check if that's all right, and if that's all right, we say fine. An EICR will check virtually everything on that circuit, check every socket and every light. So there's a big difference in how comprehensive it is. So yes, you should get an EICR recommended. Sir?
Just with regards to the replacement of the changeover of the recs associated from an old Wilex to a plastic back to a metal.
Yeah.
So if you're, for example, you had the replacement of the old Wilex to a plastic, you said about 5 years ago, then there'd be a fixed wire test, and you got that scenario, it's under the stairs. Wouldn't that come under a category of Cat 3 with regards to refurbishment, or is it under the health and safety? You're saying that it needs to be replaced because it just seems a bit. I mean, it would be like electricians just rubbing their hands, kind of, I mean, is that necessary?
I agree with, and you ask 10 electricians, you get 10 different answers. To be honest, what happened? The regulations that we have apply to now. However, we're often looking at a property that may be 50 years old, and we only need to make decisions about what is unsafe. What is actually unsafe? The fact that you have a plastic board from the past, or one with fuses in it from the past, doesn't make it unsafe because it's still doing its job. Okay, it may have no RCD protection. I might recommend RCD protection is a better thing to have, but it is not considered unsafe according to the regulations. Did that answer your question?
Well, no, we just with regards to the under the stairs scenario, because I get it, for example, for a community under public assessments, I understand that, but I don't kind of understand it under a domestic scenario. So if I go and do a survey, I'm looking under the stairs, and I can see a modern 5-year-old consumer unit with RCD or RCD protection.
Yeah. Is it a metal box under the stairs?
No, it'd be a plastic box.
Right.
It was installed 5 years ago.
Okay, so my opinion, right, if I was doing an EICR for that, I would give it a code 2. And the code 2 means it's unsatisfactory because it should be metal. Another electrician might give it a code 3, which means it could be improved, but it's considered satisfactory. So there are different opinions. I would, in a situation like that, ring up NAPIT and ask somebody who's got many years' experience, knows that regulation's inside out, and I'd say, what do you think I should do? And he might say, it's your decision, because, you know, or he might say, no, regulation 456.36821 says this. And I say, all right, I better do it, then I'll advise the client. So the thing is, these are electric difficult questions, you know, let alone for people who aren't electricians. Yeah?
Awesome. I get it, but I was always under the impression from previous training that it would be a category 3.
I'm not familiar with what category 3. Do you mean a C3, code 3?
C3.
Okay.
So, for example, if it was to be fully refurbished,
yeah,
the house would need to be refurbished, then it would meet the new addition regs. But with regards to, I can see the Cat 2.
Yeah.
But I still feel it was kind of playing into the hands of electricians that are kind of just, you know, making lots of money and a little bit of scaremongering. I don't know.
I'm sure there's a lot of that or some of that goes on. And it may be that you found a point in me as an electrician that I didn't have the right answer according to the regulations, because that may be correct, that it's perfectly acceptable to have a plastic distribution board under a staircase, and there's no requirement to make it metal. And I would certainly, because I can't be sure that I know, I would ring up and get help making that decision. Yeah. But there are many, many areas in the work that we do where a decision has to be made, and the decision is going to be as good as the electrician. And also, some of it is common sense. Sir?
I read through an EICR recently, and it got satisfactory with a few C3s. But there was a caveat in it that only around about 20% of the outlets have been tested.
Yeah.
Is that normal?
Yes. There's a part of an EICR, and again it's in your notes, called limitations. We limit the amount of investigation we do, because otherwise we'd be there for days, even with quite a simple installation. So it is quite common for 20%, we test 20% of the accessories. And test means plugging something in, getting some readings, but also unscrewing it, taking it off and looking inside. And in fact, PAT testing, which is part of electrics, not part of what I do anymore because it's so boring, PAT testing. But PAT testing, 95% of what you'll find that's wrong is simply from feeling the cord like this and looking at the plug. 90% of problems are found that way. You know, undoing anything and checking it with a meter is actually going to only find a few things. So very important to remember. That's why I pointed out earlier your 5 senses, you know, smelling it. If you smell an electrical smell, do something. Don't just pretend it's not my house, I don't care.
Sorry, so I've just got a little bit confused with this whole stair thing. So the regulations are that if the unit is under the stairs, it must be a metal.
I don't know if it must be metal.
Oh, okay. But the reality is that's the safest.
If we were changing the board, I mean, it's some. Let's say I'm talking to the client and we found a number of problems and I've talked about them, and I say, if I was in your shoes, I'd make that a metal board. I know it's expensive. It's also, I'd say this to the client, it's also an investment in your property, because that metal board under the stairs appears on your paperwork. It will help when you sell the house 5, 10, 15 years from now. So I would talk them through it. Often they would make the decision rather than me. I don't even need to know the regulation. I can describe the risk. Yeah? So?
Yeah, what would be an estimate to replace the plastic to metal? What would you charge?
Depends on the size of the board. This board, that board, because these are more expensive. If you want a cheaper electrician, you get a dual RCD board. I don't ever fit them because I think the extra money is worth it. From my point of view, testing it's easier, and from the customer's point of view, this is simpler because only one of those will trip off. You don't have the mixture of RCD and trip switch. But this board costs, and it's also got surge protection in. So this board is probably £300 or £400. And then you need to look at my labour. For a board this size, it is probably, how many circuits we've got? 2, 4, 5, 6, 7 circuits. I'm going to make a quick guess. So I think you're talking £700 or £800 for replacing a board like that. Yeah. Ask me on the phone if you've got something in front of me that. Yeah. Any other questions?
To get off the subject of distribution boards.
Go on.
We've been sticking PVC insulated to an earth cabling since when? Middle to 60s. Does it, apart from mechanical damage where someone squashed it under a floorboard or bent it around the corner several times, does it deteriorate?
Yes, it does. 50, 60 years. Yeah. Yes, and how long an installation will last depends mostly on the cables. There's two things about the cables. One, the quality of the cable, because I have heard of people buying cable, brand new cable, and there's faults with it. The copper is broken somewhere along its length, or the insulation, and you can't see it because it's under the surface, is touching. And you only know by testing. You say, this cable is brand new, how can it be like this? It's produced in a factory in China. Somebody said, make it cheap, make it cheap. So it depends on the quality of the materials. It also depends on the quality of the workmanship. And for instance, don't feed a cable through somewhere it can get squashed and other things. But you can expect wiring, if it was done well, good quality materials, 50, 60 years. And I have to say the wiring in our house is at least that old, the old Victorian house. I have never checked anything. I know damn well it needs a rewire. I think we're about into question time now. Time for a sip of water.
Go through some slides. You can carry through. You've got a few more slides there, don't you?
I have got some more slides. Yeah.
Okay.
Right. Let's see what we've got. Oh, we've got some really interesting ones to come. Right. This was a picture. This is a fireman's gloved hand. And he's holding the inside bits, the terminals of a plug like this, right? And he's holding them. This was the cause of the fire in my sister's house. Why I was concerned is I'd done some electrical work in her house. This is where, and I knew afterwards I hadn't touched this socket. So this plug or socket started the fire. And I'm contrasting there with what it should look like. There we are. You see, those are can you see the 3 bits? These are the 3 terminals that you can see on the end of those cables. So I thought you'd like to see that. That was, her house smelt for weeks. Oh, it was absolutely disgusting, horrible. This is a rewire that we did about less than 2 months ago. There was a problem, we'd just done it. There was a problem with one of the circuits, one of the socket circuits. And I tracked it down to this socket. The problem is inside this socket, and we need to home in to see what that problem is. So we home in a bit. Can you begin to see the problem? Now can you see the problem? Right, so carelessness. It wasn't me who did this socket, fortunately, but it could have been. Carelessness. If you look at that point there, the inner insulation, the blue plastic inner insulation on the neutral wire has been scraped, and it's bare. Now, there it's not a problem, but when you push the front of that socket in, that wire can touch the metal box. And if you remember, the metal box should be earthed. So the neutral and earth are touching RCD trips. So the RCD on this circuit could not be reset till we found this problem. And the problem appeared, the RCD, as soon as I pulled the socket away from the wall, the RCD stopped tripping. So I said, it's got to be inside here. And so I started looking very carefully inside, because that is almost not visible. As I may have said sometime earlier, electricians attract particularly people who are slightly autistic, because some autistic people are very good at the detail. They're not so good at communicating. And this sort of thing, you know, see something tiny, you have to find that, otherwise none of the ground floor sockets work. It's a serious problem. This might take hours to find that particular socket with a problem like this. You know, ultimately, if we can't find the problem, we have to say, well, scrap that circuit, we're going to run new cable for all the sockets again. You know, that's not what we want to do. What other nice pictures I've got to show you? You've seen this sort of thing in hotels and shops and so on. What you don't know is if you look behind one of those, and this has only got 4 switches in it, right? Look at the mess of wires. You need a lot of concentrating on detail. You open up one of those things, you right? You've got to take it very carefully, one step at a time. This, I don't know how somebody got this picture, came off the internet. It's a mouse chewing through a cable. You can even see the bits. What else have we got? This is actually not England, because this is not following English regulations. It must be America. But it's an example. It's a ceiling you're looking at there. And these are light fittings. And the cables are running through holes drilled in. Now, why I wanted to show you that is because when you put the ceiling up, you might have, this is now the UK, this is somebody's run cables in the ceiling, and you can see cables drop through for the lights. And you'll notice quite a lot of them have got two cables, because it's the switch live, coming to switch that light on, and then going on to the next one. So that's why you have a lot of complex wiring behind there. And then particularly, I wanted to show you this. How do I make this go? It's a video. How do I make a video go? First time I've ever used PowerPoint. That's it. It's only brief. Right. So, changing light fittings. Brilliant idea. Brilliant idea. But watch what happens. I'll have a go at that. Oh, yeah. Great idea. There we go. Nice and firm. Yeah. Oh, doesn't seem to work, really. Oh, dear. Well, I thought it was funny anyway. This is a block of flats. You can see here, flat 1, 2, 3, and so on. You've got, this is your main incomer with, this is from the electricity, whatever the electricity supplier is. And it's actually, there's 3 phases there, 3 fuses. Those fuses are not the property, they're not owned by the person who owns these flats. They're not owned by the building owner. This and the meters belong to the electricity supplier. So that's all there, and you don't touch them. These fuses are to protect their cables under the ground. If one of these goes, that's bad news, because you usually have to call them out, and they say, why has this gone? I've broken one of those before. Fortunately, I managed to get a spare, because the electricity company coming out and saying, what have you done here, mate? So these virtually never go. And then what we've got up here, because this only protects the live, the neutral is separate. So the live and neutral is run from your incomer through the meter, and then it goes to each of these. Now this, let's say flat 2 here, in there you've got a switch to switch it off, and you've got one fuse, and that fuse is just to protect the cable from there to the flat, which might be many meters away. And if something went wrong along that cable or inside the flat, this would go to protect all of this. So that's all these are. So they're small distribution boards with one fuse in. You've just got one fuse and one on-off switch. That's like a main switch. We don't bother to have RCD protection for these cables because generally they're armoured cables. However, none of those are armoured cables. Armoured cables are very specially, they've got steel, it's about as thick as your finger, black, and it's got steel band round it. So if you tried to go through it with a spade, it would protect it at least to some extent. And this is just an example of, it looks messy, but it might be perfectly okay. Things are all at an angle. I know the front cover's off, and it's messy because it's inside a cupboard. And I would say whoever's the electrician who's done this, he could have spent 10 minutes tidying it up so it looked neater, because it gives confidence. Right, I think, ladies and gentlemen, we've come to the end. Let's just see, we're nearly here. Needing rewire. That's it. Ladies and gentlemen, it's been a pleasure.
Thank you.